What did you say, Fonzie? Let me see. You said Fonzie. Oh, Fonzie. So, when was X-rays discovered?
November 8th, 1890.
1895. Yes, thank the Lord. Everybody knows that question. So, when X-ray was first discovered, was it as safe as it is today?
No.
No, so people didn't know what X-ray was. That's why it's called X-ray, because they didn't know what it was. Who discovered the dangers was Thomas Edison. So he noticed that after he was experimenting with X-rays, he had some injuries to his hands and face, and he's like, oh, I guess these X-rays are not as safe as I thought it was.
Ma'am, is it the same Thomas Edison who discovers the steam engine? Because that's
Probably. I don't remember right now, but maybe, yeah.
Because that's when God was with Thomas Edison.
Yes. And Thomas Edison also had an assistant that would help him with these experiments, Clarence Daly. He kept doing the experiments, and then eventually he had severe radiation burns and eventually ended up dying. So back in the day, they didn't really have any treatments for radiation burns. It was just, oh, you burned your hand, time to cut it off. Yeah. So it was very common for people to have amputations and also to have gloves on top of their hands to hide the injury. So that was in the 1890s, but by 1900 they had better imaging plates and better equipment, so that kind of helped with the danger of X-rays just a little bit. But people were crazy about these X-rays. They had X-ray tablets. They used X-rays to fit people for their shoes. Like they would use live fluoro to figure out what is your shoe size. So just imagine that was just a lot of people getting X-ray for no reason, because they were just curious with what this X-ray is. This is a picture of the fluoroscope that they used to fit people's shoes. So you place your feet in there, get your feet nice and burned. Yeah. So imagine if you were a little kid and you need your feet fitted for shoes, you're getting a lot of radiation.
Ma'am, if I understood to be correct,
I'm sorry?
sorry, they put the feet in to reduce the size?
No. So they had no ways to measure your foot so you could buy proper shoes. So they were like, oh, we have this amazing new technology, X-ray, so let's use this to measure the feet.
So they took out the X-ray and get the size from it probably.
They were just very, I guess, amazed by this technology, and they thought they could use it for whatever. So, units of measurement. Can you guys give me some examples?
Centimeter, yard,
Inches.
Okay, good. So, do you think they're important in our daily lives and communication?
Yes.
I think so.
You probably use it at least once a day, right?
Yes.
Yes. Like, oh, I had 1 cup of, I don't know, milk, or
I need a
glass of
gallon
wine,
or some ounces.
there you go. In her case, I had 2 shots of tequila. So it's ways to explain and kind of tell people the measurement. So there's 2 systems of measurements. One is called the SI, which we'll get into later. But there's 3 different quantities of measure, or units of measure. The first is fundamental, which is mass, length, and time. And then those 3 can be further divided into derived quantities. So from mass, length, and time, we can get velocity, acceleration, force, momentum, work, and power. And then this is the one that we're interested in: radiation dose, dose equivalent, exposure, and radioactivity. So make sure you know the difference in those 3. Any questions so far?
I'm sorry, wait, are we getting these PowerPoints?
Yes.
Okay. Like, after the lecture or?
After the lecture, yes.
August.
By the way, did Mr. Fong say he's gonna pass out the PowerPoints? Was
Oh no, because he had a jacket on.
Oh, okay.
He looked spiffy because he was short.
Yes.
Do we
In
have
fact-
to know how to convert, like the formula to convert everything?
Oh, yes. We'll get into that later.
You know, Mr. Fun gave us a chart.
I'm ready.
He did?
Yeah.
Yeah, he did.
She's like, it's
He would put it in the test, you know, like in the tubes, you would have it there.
So like, give me an example of what.
Instead of having the actual, I don't wanna say equation, what's the other word for it? Formula, what
Oh,
was
okay.
that?
had a
Instead of us
chart.
memorizing the formula, he had a chart that showed all the formulas. Like the
Okay.
formula for volume and that.
Okay.
Yeah.
I think we got some formulas.
Good thing I kept my education.
We're just waiting on Melanie to finish taking notes.
I'm trying to pass this class.
So these are the two different systems. We have the British system, and then we have the SI, or System International, also known as metric. So metric is when you use kilogram, meter, kilometer, second. So pound, foot, and second, these are all used by British system. So in the US, do we use SI or British?
British.
Yep.
Also pay attention to what belongs to what. Like if I say, what is the SI unit for length? It would be meter.
But,
Huh?
oh, sorry.
Wait, what was your question again?
A meter.
If I had a question, what is the SI
A
unit
meter.
for length? Meter. SI stands for international number. And then SI unit for mass, kilogram. If I asked you what the British system was, it would be pound or foot.
Doesn't British people use SI unit?
I think so,
Because
but I
they.
don't know why it's called the British system.
Yeah, that's weird.
They just have too much time. So these are some of the formulas that we'll be covering in this chapter. Velocity is a way to measure speed. So we get that by dividing distance over time. And then velocity can be expressed in meters per second. Acceleration, we'll get into the details shortly. Force is mass times acceleration.
And then I know we learned it already, but can you explain derived quantities? Like,
Yeah, give me 1 second. So fundamental quantities, that's basically like the foundation, or where it starts. So there's 3 fundamental quantities: mass, length, and time. And then from those 3, we have the derived quantities, right? Velocity, acceleration, force, all of these are under fundamental. And then these are just specifically dealing with radiology. So, let's talk about velocity for a second. V equals d over t. What does that mean?
Distance
Distance
divided by time.
traveled divided by the time needed to cover that distance. So, if we had this question, what is the velocity of a baseball that travels 20 meters in 2 seconds? So all we need to do is plug it in, right? V equals, what's our D? 20, and then our T is 2. 20 divided by 2, 10. And then velocity is expressed in meters per second. So that would be our answer. So basically what that's saying is our baseball traveled 10 meters per second. We good so far? So like I said earlier, velocity is a measure of speed. Why are we interested in velocity?
Because the speed of the X-rays, you want to know?
Yes, what is the speed of X-rays?
3 to the 10 to the 8 meters per
3
second.
times 10 to the 8th, which is also the speed of light. So X-rays are traveling that
Oh.
fast for us to be able to see that image, right?
Mhm.
so this is important, may or may not be on your
I
test.
was just saying, see, it's in red. Does that mean anything?
This is the first time I heard that X-rays travel at the speed of light.
Yes.
No, it's not, Mr. Holmes.
Yes. I'm very glad that I didn't
Oh,
travel.
I'm gonna tell
sorry.
Mr. Brown.
And well, he had it like a long
Explanation for it, but he said.
Oh,
It was not many times. He had like a actual number.
he had it written out?
Yeah.
Yes.
You know,
Mr. Fong is extra, but we love him.
but we love extra food. It makes me happy.
It's good, it's very helpful also.
Speed of light. So we said velocity was a measure of what? Speed. So what is acceleration?
Change of speed.
Change in velocity. So if we have one velocity and then another velocity, that change would be measured as acceleration.
So the change.
So in X-ray, how do we deal with acceleration?
Increase KVP.
Don't electrons have to be accelerated to hit the target?
Yeah.
From the building.
Exactly. So the formula for that would be VF minus VO divided by T. Now, it may seem like it's a lot of letters, but basically you're getting the final velocity of whatever situation minus the initial velocity, original velocity, divided by the time. Make sense?
And the what you call them, meters per second square. Well, the Unit
How it's
time.
written, yeah, I'll tell you in just a second.
velocity meters per second. Meters per second.
So, same, it's not same, but similar question from earlier. What is the acceleration of a baseball if the initial velocity is 0, meaning it was at a standstill? The final velocity is 10 meters per second, and the time that it took for that acceleration is 2 seconds. So, all we need to do is plug in those numbers to our formula, what was our formula for acceleration? Yes, so final velocity, which is 10, minus 0, which is 10, divided by our time, which is 2. So that would be our acceleration. So the baseball had an acceleration of 5. Everyone good?
Wait, so are we about to start learning like this? Like, so we're gonna have to find out like the acceleration. You have that example that you gave earlier with the what did you say, the electron?
Electrons?
Yes. Are we about to start having to put that into these?
Not specifically that, but we're gonna get into some math when it comes to like the X-ray circuit. So this is just prepping you for that. And then we have some more units of measure. When we talk about energy, that just means that energy is simply the ability to do work and has 2 states. We have a potential energy, and then we have a kinetic energy. Potential energy is basically something that has potential to have that energy, right? So it's energy that's stored. It's in a stored state. Kinetic energy is when the energy is actually being used or expended. For example, if we have some batteries and they're just laying there, it has some sort of energy. Would that be potential or kinetic? Potential. But when we're using something, using the battery and it's working, that's using kinetic, right? It's being expended.
Expended means used.
Being used, or the act of using. And there's many other forms of energy like electromagnetic, electrical, chemical, thermal. What kind of energy do you think X-rays use?
Heat, thermal.
Both. Electromagnetic and thermal. Thermal from what? Or how do we have the heat? From the heat, right? And then electromagnetic,
Is the running around of the electrons.
something else?
Magic.
how do we send?
And the thing.
Yes, because what is the cathode and anode?
Positive,
Positive
and negative.
It's electrodes, right?
Okay.
So voltage needs to be applied for that whole process of thermionic emission to start
move.
happening, right?
Mhm.
Because if we don't press that button, is it
Nothing.
automatically creating electrons?
No.
Right? We have to send that voltage across. So that's how it's electromagnetic and thermal.
The cathode and the anode send voltage across, and the sending of the voltage across is magnetic.
No, the voltage is electro. The electromagnetic is there's a magnetic field that's created when all of this is happening. And then chemical energy is any sort of energy that exists through chemical reactions. It has nothing to do with X-rays. Should I move on? So these are the terms that you have to familiarize yourself with because it pertains to radiology. So these are all the terms under the British system, but these are the terms that they use for the SI system. So all of these equals to whatever's next to it.
Mhm.
So if someone says it was 2 rads of radiation to the liver, that can be converted to the to grays in the SI system. Because these are equivalent. Does that make sense? So rad is gray, rem is sievert. Easy way to remember is that rad has an A, so does gray. REM has an E, so does sievert. So then you have to just figure out the other two.
Mhm.
And this
I remember curious with that girl because they both have views.
Ah,
They
good one.
see
Mhm.
too.
I just think about
What was that?
barbecue.
Oh, see.
Yeah.
Barbecue.
And then I just know what it, I don't know, that's
Barbecue.
just me, that's just me, so.
Yep. So what's the SI unit for radiation absorbed dose?
Right.
Gray.
I was like, what? I was like, wait a minute, really?
RAD stands for radiation
Yeah.
absorbed dose. What is the SI unit for radiation equivalent?
Sievert.
Or I can ask you the same question flipped.
Oh, yeah.
Correct. So the coulomb per kilogram, what was this equal to, by the way? Rankine.
Rankin.
So that is a measure of the number of electrons that are liberated by ionization in air. What is ionization?
Dividing into electrons.
It's right up there. Removal of electrons from atoms. So when we make an exposure, does that X-ray go straight to the patient, or does that actually have interactions in the air itself? It does, right? We have scatter radiation. That's where we stand behind that lead wall. So the coulomb per kilogram measures the ionization that happens in air. Does that make sense?
Yes.
And then these are some numbers that you have to remember, unfortunately.
No, I really give us.
And this is important to know. An ion pair is an electron that's removed from one atom and the atom from which it came. And then when the two together come together, they form what's known as an ion pair.
From the atom and the ion that together.
So if there's an atom and the electron is removed from that atom, the two together,
The electron and that original atom.
yes, that's called an ion pair. Don't look so sad. I think this is where I wanted to stop for today. The relationship between coulombs per kilogram and Rankine is that one of these equals 3,876 Rankins. Or on the flip side, if I asked you what is one Rankin, it would be this.
One by.
How do you think I got this number, or how did they get this number?
So 1 divided by 3,876.
Yep. That's just this written out. So, what I'm asking is, they told us that 1 coulombs per kilogram is that many Rankins, right? So if I had on the test, one Rankin is how many coulombs per kilograms, how would you calculate that?
What was the question one more time? If you put what on the test?
If I give you this up here on the test,
Okay.
and then asked you, what is 1 Rankin, how would you calculate that?
Oh my god, I don't even know where to start.
You divide both side by 3,876.
Yes, what you would do is divide 1 with this, which would give you this answer.
Wait, but
Like basic algebra.
would you put that decimal or the other number?
Either or.
Oh, I don't know how to read those.
You don't know how to read what?
The 2.58 times 10 minus 4.
You just put in the 0.58 times 10 to the power of negative 4.
Oh, it's
That just
power.
basically means
1 over 10
all
to
the
the power
zeros.
4.
Oh, it's
Underneath.
power of negative 4?
Oh, did I? My
Yeah,
bad.
It says
I didn't write it wrong.
minus
It
4.
should be a subscript. I'm sorry.
It's not small.
Wait, but so if you divide it with a calculator, is it gonna show you to the power of negative 4 or something?
If you use a calculator, it's probably
all
gonna
we
give you
basic
this
terms.
number. Unless you have
No,
a
I know how to
scientific
read
one,
if it's power of
No,
negative
no.
4.
then it's
We
gonna
just
give you that
divide.
2.58.
Yeah, it's 1 divided by
What are you gonna do?
3,876.
To the negative 4, that's why you're going left, right?
Back with the decimal.
4 times.
On the test, I will take either or.
Now you see why you have all those points up there.
And I know that was a lot of information, that's why I'll stop there for today, because it's only gonna get harder. I do have some worksheets for y'all to practice your math.
Ms. Bonilla,
Yes.
test is multiple choice, right? Exam?
Yes.
Okay.
You guys